One of the classic categories of word problems in algebra is rate, time, and distance problems. Now to do them, we're still going to use the same basic steps of all word problems. So let's review those.
Pay attention, son.
The first step, as always, and this is the one people miss the most, I always say, is to look for what you're looking for. Name what x is. And remember, it can only be one thing. It's usually next to the question mark. If you have a choice between several things, let it be the smaller one. Okay, so name what x is. And then define everything else in terms of x that's an object in the problem itself. Okay, and I always tell people to cross out as you do that, because what's left is going to be the equation in general. Then we solve the equation, and once you solve the equation, you just know what x is. We have to, of course, at the end, answer the question. Okay? Well, there's going to be some additional tricks, or more specific tricks, if you would, with rate, time, and distance problems. Generally, for steps 1 and 2, where we name x and everything else in terms of x, we're going to use a chart
Perhaps I could be of some assistance.
that looks like this. We're going to have more than one object moving at one time. That's why we need a chart. Okay? So you'll have two rows of object 1 and object 2, and then we'll try to define the rate, time, and distance of each of those objects in the problem. Now, generally, we're going to fill in 4 of the 6 boxes from information directly given in the problem, and the other 2 boxes are going to get filled in by one of the rate, time, and distance formulas. I call these the hard boxes, and generally those are the 2 boxes we're going to relate in step 3 where we write the equation. Okay, so we'll fill in the hard boxes using rate, time, and distance formulas.
Wait a minute.
Oh, I guess I have to tell you those formulas. I bet you already know them, though.
Are you pondering what I'm pondering?
Consider, if you drove 60 miles an hour, that's a rate, for 3 hours, wouldn't you have gone 180 miles? I think you already know that distance equals rate, or speed, times time. What if you had to go 200 miles and you had 4 hours to do it? How fast would you have to go? Per hour, anyway. 200 miles, 4 hours to do it. You'd have to go 50 miles each of those hours, wouldn't you? I think you already know that rate is distance divided by time. Well, that makes sense. If distance is rate times time, we would divide distance by time to get rate. In the same way, if you had to do that 200 miles and you could only go 40 miles an hour, maybe you were on a moped or something, how long would it take you? Well, it would take you 5 hours, wouldn't it? Because you know that the time it takes you is the distance divided by how fast you go, divided by the rate.
Alrighty.
So in general, the formulas are that distance equals rate times time.
You're absolutely correct.
Rate is distance divided by time.
Darn tootin'.
And time is distance divided by rate. Now really, you don't have to memorize those. You can really kind of derive them if you just remember that distance is rate times time and then solve for the one that you want.
Allow me to demonstrate.
Okay, let's do one. As usual, this problem is going to have 2 objects of some sort moving at the same time. So,
Perhaps I could be of some assistance.
we'll use our chart. Let's see. A passenger train travels at 80 miles an hour. A freight train travels at 30 miles an hour. If they travel in exactly opposite directions, how long will it take before they are 275 miles apart? Can't do that one in my head. So let's use the chart. Step 1. Name what x is. What do they want to know here? Well, I kind of helped you out with the color. How long? So x is time, isn't it? Okay. And they're both going the same amount of time, so I can actually, and sometimes you can do this. You can put the x in more than one place. Okay? I'll cross that out. Now let's define everything else in the problem that we can get. We need to get 4 out of the 6 boxes, and we have 2 of them already. Well, let's see. A passenger train travels at 80 miles an hour. There we go. His rate is 80. And I'll cross that out. The freight train travels at 30 miles an hour. I can put that in and cross that out. Now I already have 4 out of 6 boxes. I fill in the other 2 using the formula. Distance is rate times time, so 80 times x for the passenger train.
I know that, dude.
And 30 times x for the freight train. Okay, and these are the 2 boxes that I'm going to relate in my step 3 where I write the equation. Now, the distance that the passenger train went, that's what's represented by 80x. The distance that the passenger train went plus the distance that the freight train went is going to have to equal this 275 miles because they're going in opposite directions. And that's going to be your equation. Now let's solve this equation. Let's add like terms. 80x and 30x is 110x. And solve for x by dividing both sides by 110. And I get that x is 2.5 or 2.5. Now that's x. Oh. I have to answer the question. The question is, how long before they're 275 miles apart? How long in time? Well, since the unit of time that we used was miles per hour, I know that the answer is 2.5 hours. And that's your answer. Note that whatever unit goes in is going to be the unit that comes out.
Please come again.
Let's try another one. Sue can ride her bike 12 miles per hour faster than Mary can walk. Now Sue rides 95 miles in the same time Mary walks 35 miles. Well, these are some serious jocks. The question is, what is each person's rate?
Perhaps I could be of some assistance.
Once again, let's start off with our chart. We're going to have our moving objects, in this case, Sue and Mary. And let's define what we're going to let x be. Now, it wants to know each person's rate. I need to pick one of the people. I'm going to try to pick the slower one. Well, who's going to be the slower one in this case? The walker, I assume. Mary can walk. So her rate is going to be x. And then I'll define everything else in terms of x. Okay? Well, let's see, what else do I know? I know that Sue can ride her bike 12 miles an hour faster than Mary can walk. So I put in x plus 12 for her rate. Okay? And I'll cross that out. The distance that Sue rides is 95 miles. So I put a 95 in that position. And cross it out. And the distance that Mary walks is 35 miles. And I always like to cross these things out. Okay, now we filled in 4 of the 6 boxes. We fill in the other box with the formula, the appropriate formula for time. Now time equals distance divided by rate. So 95 divided by or over x plus 12. And Mary's time will be 35 over x. And now, what have I not crossed out? That's what's going to come into play when I write the equation. Well, that's why I like crossing out. These times, these hard boxes, it says right there, are the same. Sue's time is the same as Mary's time. And there's your equation.
Excuse me, Professor Brainiac.
Oh, we're going to have to solve the equation. I hope you remembered what the secret to solving equations that have fractions in them is. We're going to multiply both sides by the least common denominator. And the least common denominator in this case is x and x plus 12. Because I'm not going to be able to cancel things that are added, so I need that other x. Okay, if I do that, that's going to cancel nicely, and on the left side, I'll get 95x. And on the right side, I'll distribute the 35, and I'll get 35x plus 35 times 12, or 35x plus 420. Now let me solve this one. Much easier. Subtract 35x from both sides. And now all I have to do is divide by 60.
Certainly.
And I get x is 7. Now wait a minute.
Oh, no you don't.
Okay, now let's get this straight. Whatever unit goes in is the unit that comes out. And what was x? I look up at my chart. Good thing I made that chart. X is Mary's rate. A rate is miles per hour in this case. So the answer is 7 miles per hour. Mary goes
The important thing is
7
your final
miles per hour. Oh, and they also want to know Sue. Good thing I wrote that in the chart too. Well, Sue is x plus 12. So 7 plus 12. Sue rides 19 miles an hour. And that makes sense, doesn't it?
You just want to be.
And that's about as hard as it gets, okay? Remember that when you want to solve a fractional equation, they're going to occur a lot in these type of problems. You're going to multiply by the LCD, okay?
Elvis has left the building.
Go try that homework.